Study section 11. Time series analysis. Introduction. Time series analysis is the application of time series technique to time-structured data, usually referred to as time series data. Time series data is the record of observations measuring certain quantity of interest at regular or irregular interval of time. The observations may be recorded daily, weekly, quarterly, yearly, or biannually. It is a realization of sample function from a certain stochastic process. Time series occur in many fields such as agriculture, engineering, business and economics, geophysics, medical sciences, meteorology, quality control, social sciences, and so on. In this study session, you will learn about the time series data, methods of analysis of time series data, and the components of a time series. Learning outcomes for study section 11. At the end of this study, you should be able to define and identify a time series data. Identify the methods of analysis of time series data. Estimate and isolate the components of a time series. Time series analysis. The goal of time series is to identify a model within a given class of flexible model which can reasonably approximately express a time-structured relationship of the process that generates the data. The original use of time series analysis was primarily as an aid to forecasting. In the recent time, the task has grown to an extent that time series analysts develop reasonably simple models capable of describing the system that generate the time-structured data, making reliable forecasts for the future and testing of hypotheses. Uses of time series models. Time series analysis is the study of the time-structured relationship in a variable. This involves the use of the basic tools to analyze a given time series data with a view to construct simple mathematical systems that explain the time-structured relationship in the economic and social series in a concise way. Use the model to explain the behavior of the series and make reliable forecasts for the future on the basis of the dynamic dependence of the series on the past values. Thus, time series provides a basis for economic and business planning, production and system planning, control and optimization of industrial process. The intrinsic nature of a time series is that its observations are dependent or correlated, and the order of the observations is therefore dependent. Since life must be understood looking backwards and must be lived by looking forward, time series provides useful tools that helps to predict the future by approximating models that use past data. Discrete time series is one where observations are taken at discrete specific time intervals, usually equally spaced, e.g., interest rates, yield, volume of sales, and production. Such series arise from fields such as agriculture, business cycles, etc. Continuous time series are observations taken at any time t is a member of T in the index set T. This type of series are common in the engineering, geophysics, and medical sciences. In-text question. Methods of analysis of time series data. Time series data can be analyzed using either the deterministic method or dynamic method. Deterministic method. A time series is said to be deterministic if future values are determined exactly by some mathematical function. For example, 1. Yt is equal to a plus bt. 2. Xt is equal to cos into bracket 2 pi t, where a and b are constants and t is time that is fixed. 3. Xt is equal to tt times st times ct times it, where tt is the trend component, xt is the seasonal component, CT is the cyclical component, and it is the irregular component. Dynamic non-deterministic method. A time series is said to be non-deterministic if future values can only be determined in terms of a probability distribution guided by some assumptions. For example, 1. Yt is equal to far 1 yt minus 1 plus far 2 yt minus 2 plus epsilon t. 2. Xt is equal to a sine into bracket wt plus theta, where epsilon t is normally distributed with mean 0 and variance unity, a is a constant and theta is a random variable from a uniform distribution on the interval minus pi in bracket independent of a. This method involves the use of autocorrelation function ACF and partial autocorrelation function PACF and correlogram in discrete domain. It also involves the Fourier transforms in frequency domain analysis. If frequency domain is carried out using the extension of Fourier method and spectral density function. In-text question. Deterministic time series analysis. The analysis of time series depends on the type of system that generates the data. Analysis in time domain refers to the analysis of discrete time series. Simple descriptive analysis. Most social and economic data, including data generated in medicine, are time-structured. They need to be summarized with a view to make inference about the system that generates the data. Time plot. The first and most important diagnostic tool of time series data is the time plot. It is a graphical representation of a time series data. It is constructed by plotting the observation x1 on the vertical axis against time t on the horizontal axis. When properly drawn, it shows up the important features of the series such as trend, seasonality, discontinuities, and outliers. The time plot of the data gives an idea of the type of model that is suitable for the data. It could also indicate whether it would be necessary to transform the observed data to achieve certain stable conditions suitable for meaningful analysis and inference. Time plot of xt. Figure 1.1. Time plot of a series. Components of time series. Movements in a time-structured data are governed by some peculiar and inherent forces which may be characterized by their regularity, periodicity, and their effect in the entire series. The forces could also be due to changes in the social, economic, psychological, or environmental characteristics in the system. The patterns generated by these forces are referred to as components of time series. Some of the components are the trend, TT, seasonal movement, ST, cyclical movement, CT, and the irregular movement, IT. Trend or circular movement. This is the long-time movement in a series in the same direction over a long period of time. It is usually characterized a continuous increase or decrease in the values on a variable over time. This movement is generally referred to as circular variation or circular movement. A line can be freely drawn by hand through the plotted point on the graph of such time series stretching over a long period. Such a line called a trend. It is denoted by TT. The time plot below shows trend in a series. Figure 1.2. Time plot showing trend. Trend can be upward or downward. Upward trend is displayed in the time plot. This type of plot is expected from sales of a commodity where increase is always expected. Seasonal variation. This refers to identical or almost identical patterns which a time series appears to follow during corresponding months of successive years due to mainly recurring event that takes place annually. The movement appears to be periodic, exhibit variation at a fixed time within a given interval if time. Many time series, such as sales figures and temperature readings, exhibit variation which are periodic annually. There are factors responsible for this repetitive pattern year after year, and the major factor is weather condition. During winter, more woolen clothes are sold in UK and some other parts of the world. Also, regardless of increasing trend in the sales of ice cream, there is more sales of ice cream during summer than winter. Seasonal variation is denoted by ST. Time plot showing of monthly number of rainfall is given below. Season is completed within 1 year, therefore a complete cycle is detected in the time plot below. Seasonal variation is also found in a quarterly data. In that case, a complete cycle will be completed within 4 quarters that make a year. Figure 1.3 time plot showing seasonal variation. Cyclical variation. Cyclical variation refers to as a long-term oscillation about the trend which may or not be periodic due to some other physical causes. The movement may or not exactly follow similar pattern after equal interval of time. Examples include daily variation in temperature and rainfall as well as some social and economic variables. A cyclical variation is denoted by Figure 1.4 time plot showing cyclical variation. Irregular variation. This refers to erratic or sporadic movement of time series due to occurrence of random perchance events which are unforeseen, hence it cannot be isolated directly. They are not deterministic. These variations may or not be random, though it is assumed that these chance events produce short-time variation. However, they can be very intense and may result in a new cyclical or other variation. Included among these random factors are such events as strikes, flood, volcanic eruption, earthquake, fire outbreak, sudden change in government policy, and so on. It is denoted by 8. Method of combining components. The task of the statistician is to segregate each of these factors in so far as this is possible. By isolating or removing individual components, the impact of each of the components may be assessed. It may happen that not all of the components may be present. Traditionally, it is possible to decompose time series into the trend, seasonal, cyclical, and irregular components. Using either of additive model, xt is equal to tt plus st plus ct plus it, or multiplicative model, st is equal to tt times st times ct times it, where tt is the trend component, st is the seasonal component, ct is the cyclical component, and lt is the irregular component. The resulting trend equation can be used for forecasting, while the original data can be deseasonalized. For example, the trend can be estimated using either 1. K-point moving average, 2. Semi-average, 3. Least squares method. Assuming all these methods are familiar to us, the least squares method uses the normal equation xt is equal to a plus bt plus et, with the assumption that the error term et are independent and not really correlated. Otherwise, the regression equation is spurious, that is, the parameters of the models are biased and inconsistent due to the presence of a lagged dependent variable. The estimated OLS standard error is invalid. The composition of a time series can be achieved using any of the following models. A. Additive model. ST is equal to TT plus ST plus CT plus IT. B. Multiplicative model. ST is equal to TT times ST times CT times LT. C. Mixed model. ST is equal to TT, ST, CT plus LT. Or ST is equal to TT plus ST times CT times LT. We shall concentrate first on A and B. The additive model assumes that the actual values are the sum of the four separate effects. This assumption is probably true when short periods are involved or where the rate of growth or decline in the trend is small, as may be shown in the time plot. The multiplicative model suggests that the actual values are the product of the separate effects. This model is indicated when there is a marked or sharp growth or decline in a time series data, as may be shown in the time plot. Decomposition of the components. Either of these models may be used to effect the decomposition of the time series. The ideal is to decompose a time series into each of the basic components, analyze each component separately, and then recombine them in order to describe the variation in the series as a whole. The process involves systematic evaluation of each component from the data. The first stage is usually to estimate the trend and eliminate it from each time period from the actual data by subtraction or division to give a detrended series. The trended series can be obtained using additive model. XT minus TT is equal to ST plus CT plus LT, or multiplicative model. XT over TT is equal to ST, CT, LT. Estimation of seasonal indices. The first step in the estimation of seasonal effect is to obtain the deviation from the trend XT minus TT for additive model, or ratio to trend ST/TT for multiplicative model. The detrended series is averaged day by day, month by month, etc. to produce an estimate of the seasonal component depending on whether the seasonal effect is thought to be additive or multiplicative. The deviations are arranged in a table with a view to obtaining the average, otherwise referred to as seasonal indices ST. Summary for study section 11. 1. Take 2. Summary for study section 11. In this study, you have learned about 1. The components of the time series were described. Take 2. The components of time series were described with charts for their illustration. 2. The additive and multiplicative method of analysis of time series data with examples. 3. The procedure for construction of seasonal indices and deseasonalized data. Some useful examples were given to illustrate the techniques. This is the end of SAT 111. Thanks for listening. Take 2. This is the end of SAT 111. Thanks for listening.